Welcome to the tutorial on oxidation numbers. Oxidation reduction reactions are reactions where an oxidation number of a certain element is going to change. And this notes that electrons are being transferred from one element to another element. If we see those oxidation numbers change, that tells us that electrons are being transferred. All right, oxidation reduction reactions, another word for that is redox reaction. So let's take a look at some things. If we see pure elements as either reactants or products, then we know that an oxidation reduction reaction is occurring, because those pure elements have oxidation numbers of 0, as we'll see in a little bit, and when they change away from pure elements, their oxidation number is also going to change, indicating that electrons are being transferred. Alright, so if that oxidation number of an element changes, a redox reaction has occurred. So if we don't see pure elements, we still need to be able to tell if it's a redox reaction. And so therefore we need to learn how to determine the oxidation states, or these oxidation numbers. And there's a set of arbitrary rules that allow us to do that, and that's what we're going to go through on these next two slides. So if we see those oxidation numbers change, then we know it's a redox reaction. Alright, so these are the rules for identifying oxidation numbers. Oxidation numbers are like a pseudocharge. Take an individual atom and we look at the electrons that it has in the compound, and we can give it a pseudocharge. This is useful for the electron bookkeeping in these to identify these redox reactions. Alright, so there's going to be 6 rules. Rule number 1. Neutral elements have oxidation numbers of 0. I mentioned this already, but here we see some examples of some neutral elements. These all have oxidation numbers of 0. There's no charge on these elements. They're not ions. They're just by themselves. And so if we see those in a reaction, we would know they have an oxidation number of 0. We're probably dealing with an oxidation reduction reaction. Also, if we see ions, if we see an atomic ion, then that oxidation number is equal to the charge on that ion. So here's some examples of some ions that we might look at. Lithium plus. There we go. It has an oxidation number plus 1 because the charge is plus 1. Fe3 plus, oxidation number plus 3 because the charge is 3 plus. Oxygen 2 minus, if it was by itself, then it would have a oxidation number of minus 2. Alright, rule number 3. Alkali metal ions are always going to be plus 1. Alkaline earth metal ions are always going to have oxidation numbers of plus 2. And fluorine is going to have an oxidation number of minus 1. This is assuming these guys are in ionic compounds. And so here, if you are keeping track here, let me turn my pen on real quick. Group 1 are the alkali metal ions. Remember, they like to be plus 1 charge, and so we say the oxidation number on them is plus 1. Alkaline earth metals, group 2. These guys like to have a plus 2 charge when they are in ionic compounds, so their oxidation numbers are plus 2. And fluorine is usually fluoride. This is a member of group 17. And usually in compounds it's F minus, and that's why we call that an oxidation number minus 1. But not all of group 17 will have that, just fluoride. Rule number 4. The oxidation number of hydrogen is plus 1 in covalent compounds. Alright, as long as this doesn't violate one of the previous rules, 1, 2, or 3, hydrogen is going to be plus 1. So let's, we'll do an example of this here in a second, but basically, if we think of hydrogen when it's bonded to an alkaline earth metal, beryllium hydride, the beryllium we just said had to be plus 2. Well, that hydrogen, as it turns out, can't be a plus 1 because that would give this overall compound a pseudocharge. And so in this case, each of these hydrogens is going to have to be a minus 1. And we'll see that based on rule 6, what happens is the sum of all these oxidation numbers, or all these pseudocharges, is going to have to give the overall compound charge. That's going to be rule number 6. Rule number 5. The oxidation number of oxygen is usually negative 2. Again, as long as this does not violate previous rules. So let's do another example of this. We have a compound, water, H2O. Everybody's familiar with this compound. And so when we look at this, we're trying to identify the oxidation number of all the elements. Well, rule number 4 is a previous rule. It says that hydrogen is usually +1 in covalent compounds, and here we have a covalent compounds. We're not dealing with any metals. It's all nonmetals. And so we're going to have each of those hydrogens is going to be a +1. There's 2 of them, so that's a +2 charge based on the hydrogens. And so the oxygen is going to be a -2 to give that overall compound a charge of 0. So that works out. But in another compound, hydrogen peroxide, H2O2, we can't have the same thing happen, because when we use rule number 4 to tell us that hydrogen is usually +1, that gives us +2 on the hydrogen side of things. If we did -2 on the oxygens, we wouldn't come up with an overall charge of 0 when we sum up all these charges. And so in fact, the oxygen in this case, each of them has to be a -1. So there we see in a peroxide, we're going to have -1 as the oxidation number on oxygen, but typically when we're dealing with oxygen and covalent compounds, it's going to be a -2. And then lastly, we've already been using this rule, but the sum of all the oxidation numbers of all the atoms in a molecule is going to be equal to the charge on that molecule or ion. And we've already been doing that. I've been setting up these little algebra quantities. I've been summing up all the oxidation numbers in each of these to show the overall charge. So let's do a couple more examples here. Let's identify the oxidation numbers on all the compounds here. All right, so NH3. This is a covalent compound because we're dealing with all nonmetals. So the hydrogens are going to be +1, but there's 3 of them, so let's multiply that by 3. What's the overall charge on this compound? There is no charge on the compound, so these have to sum together to be equal to 0. So when we put the nitrogen in here, this nitrogen plus the hydrogens is going to equal 0. And so what does the nitrogen have to be? It has to be a -3. All right, -3 on the nitrogen, +1 on the hydrogens. That's how we get our 0. Let's look at another compound that contains nitrogens and hydrogens. And then we're going to see that we get something different for nitrogen. This time, again, covalent compound. We're dealing with all nonmetals, so the hydrogen is going to be +1, but there's 4 of them, so we got to multiply that by 4. The overall charge on the compound is still 0, so when we add the nitrogens plus the hydrogens, we're going to get 0. All right, so what is that nitrogen going to be? Well, there's 2 of them this time, so we're going to multiply whatever that number is times 2, add it to 4, and get 0. So now the nitrogen is going to be -2. All right. See how you set up these little algebraic sums to get your overall charge. Now let's do one more. Let's do an ionic compound. Let's do bicarbonate, HCO3 minus. If we sum the H, the C, and the 3 oxygens, we should get -1 on these pseudochargers, these oxidation numbers. So here, this is a covalent compound, so what's the hydrogen going to be? Rule 4 tells us the hydrogen is going to be +1. The carbon, we're not sure yet, so let's leave the carbon there blank. And then the oxygen, again, oxygen's usually -2, unless another rule doesn't let us be that. But there's 3 of them, so we're going to do 3 times the -2. That's giving us -6. And then the 1 over here, that gives us -5. So carbon plus this has to equal -1, so the carbon is going to have to be +4. +1 plus 4, -6, that gives us the -1. So that's how you go and identify oxidation numbers. You do this on each of the elements, in each of the compounds in a reaction, and then if you see a nitrogen or an element changing from, say, a -3 to a -2, you know that electrons are being transferred, and therefore you have an oxidation reaction occurring. Next tutorial will show you some oxidation reactions.